Welcome back to Math Mini Lessons. This is lesson 56 and we're going to do some more practice with 1 and 2 step word problems. Here's what you're going to see me do in the model that you're going to demonstrate during your checkpoint and your exit ticket. So one, that you can successfully write a 1 and 2 step expression from a real world scenario in a word problem. We're also going to look to see that you can translate a real world scenario into the expression and that you can use a table to evaluate your expression using different unknowns. Okay, let's jump into the very first one. If the price of pizza is $5 and the delivery price is $3, create a table that shows the total cost of the pizza plus delivery for 1, 2, 3, 4, and 5 pizzas. Include the expression that describes the new cost for ordering the pizzas. Okay, so basically, what do we want to know? They're asking us to make a table and write an expression that describes the cost of ordering the pizzas and delivering them as well. So we got to create a rule. Here's what we know. We know that each pizza pie is $5. We know a delivery is $3. And we know that you can order more than one pizza pie and they'll still only charge you $3 for the whole delivery. So here's my plan. I'm going to write an expression and find the cost for 1 pizza and delivery. Then I'm going to try finding it for 2 pizzas and delivery. And I'm going to use this to look for patterns and create a rule to help me find out the cost for any pizza. Let's start by just trying out the scenario and just imagining what happens when we order the pizza and delivery. Because we have 2 terms here, we want to figure out which one might be a constant and which one might be a variable. So pretend we order 1 pizza and it gets delivered. What would that cost be? So it would be $5 for the pizza plus $3 for the delivery, which would mean a total of $8. Let's say we buy 2 pizzas. So if I buy 2 pizzas, I'm paying for $5 for each pizza. And now let's think through the delivery. Now when I buy 2 pizza pies, are they going to charge me for twice the delivery? No. The delivery cost is still just going to be $3 because they're not charging for each to deliver each pie. It's 1 delivery. So altogether this is $13. And so if I were to buy 3 pizzas, 5 plus 5 plus 5 plus 1 delivery. So that's $18. So when we're looking here, we're looking at each situation. What is changing? What's staying constant? Well, the cost of delivery is constant. It's always $3. So I'm always adding $3 for delivery no matter how many pizzas I buy. But what's changing are the number of pizzas. And so every time I order a different amount of pizza, the cost is changing. So that's something to notice with each time. So when I buy 1 pizza, it was just $5. When I bought 2 pizzas, it was 10 or 5 plus 5. When I bought 3, it'll be 5 plus 5 plus 5 or 15. And is there another way that we can express that? Yes. So I want us to just think about that for a second. It's the pizza, and I'm going to put pizza as just P. So every single time I buy a pizza, cost is $5. So I'm going to use 5p to represent the cost for pizzas. Every single time I buy a pizza pie, that is the cost for the pies, plus my delivery, D. But in this case, we know delivery is always constant. It's never changing. It's always $3. So I'm just going to put 3 in there. So that's my expression. It's $5 for every pie plus $3 for delivery. So there we have it. We have our expression. I can use that to figure out the cost now for all the other, if I bought 4 pizzas, let's say. So it'll be 5 times 4 plus 3. Using order of operations, that'll be 20 plus 3, 23. If I bought 5 pizzas, that would be 5 times 5, which is 25, plus 3, which gives us 28. If I bought any amount of pizza, it would be 5 times that amount of pizza, plus 3. So let's hit pause so we can jot this down into our notes. we're going to continue getting some practice in looking at some story problems and trying to put this into an expression. So one of the things we're going to look for, we're going to figure out what is the variable, what is the thing that's changing, what is the thing staying constant if we see it, the value being constant, and if we're noticing any operation. And also just putting a little star order might really matter. So let's try this out. So in the first one, we already see Sammy has 2 more baseballs than his brother Ethan. Let E be the number of balls Ethan has. So they just decide, we get to decide what that variable will be. And so because he has 2 more than his brother, is E plus 2. And that's how we'll evaluate. If Ethan has 7 baseballs, we can figure that out. E plus 2, do the substitution, and we can figure out how many Sammy has. So let's try the next one. Ella wrote 8 more stories. So I could already see that 8 plus 8 stories more than Anna in 5th grade. So what don't we know? We don't know the stories, the number of stories. So let's let S be the number of stories. And this is the number of stories Anna has. So because Ella wrote 8 more stories, I would say S plus 8 will tell us what Ella wrote. So Anna wrote 10 stories. Okay, S plus 8. Anna wrote 10, so we're going to substitute this in and put in 10. So 10 plus 8 or 18, and there's our sentence. Anna wrote 18 stories. We'll do the same thing on the next one. Lisa has been dancing 3 more years than Danica. Okay, so 3 more, so I already know it's 3 plus whatever Danica danced. So let D be the number of years Danica danced. That's our expression. If it's 3 more, so it's D plus 3. So I'm going to start by writing that expression. Notice how I'm capturing it each time I'm writing it down. There's my expression, and now I'm going to substitute underneath that. And she danced for 6 years, so 6 plus 3, which makes 9. So this means Lisa danced 9 years. Hit pause so you can jot this down in your notes. The New York Rangers scored 2 fewer goals than the Sabres last night. So let S be the number of goals that the Sabres scored. And we know that the Rangers were 2 less than whatever the Sabres scored. So S minus 2. So let's try and evaluate this. So the Rangers scored 3 goals last night. So this is interesting because S is what the Sabres scored. And this will help us figure out what the Rangers scored. So what do we know? We know that the Rangers scored 3 goals. So then how much did the Sabres score? Well, what would make this true? I know some kids will either think, well, it either has to be 5 or 1. So let's play both and tell me which of these statements is true. 5 minus 2 makes 3. 1 minus 2 makes 3. One of these statements is true and one is false. And it would be the top one. So if the Sabres scored 5 goals and the Rangers scored 2 less, they would have 3. So this makes the most sense. This tells us how much the Sabres scored. S equals 5. It can't be the one on the bottom because if the Sabres scored 1 goal and the Rangers were 2 less, there's no way they could have scored 3 goals. So this one is important. I like this problem a lot because our variable does not match the actual number that was given to us in the problem. We can't evaluate for S when they're giving us what R did, what the Rangers did, not what the Sabres did. Let's try the next one. George has gone camping 3 fewer times than Dave. So we're going to say let D be the number of times Dave went camping. This is why it's so important to define what our variables are. So George has gotten 3 fewer than Dave. So D minus 3. This will tell us what George has gone. So George has gone camping 8 times. So I can't put in, if I have D minus 3, I can't put 8 for George because D is how much Dave has gone. But this will help us figure out George's part. All right, so what do we know? We know that George has gone 8 times. So how much has Dave gone? Well, George has gone 3 less than Dave. So if he went 8, Dave went 11. So we're doing a little bit more thinking here. But one of the biggest takeaways I want you to get from this is we can write expressions to solve problems. But we want to make sure the variables we're using stand for something. And we have to name that. We have to know what the variable stands for. So when we evaluate for a variable, we know where to substitute. That's going to be a big takeaway in today's lesson. So we're going to pause here for now so you can get some practice in, and I will see you on the next lesson.